Good morning, everyone. This morning we're going to be discussing the difference between observation and mathematics and how we come to different conclusions. If you go back before mathematics ruled physics, observation was the law. Tycho Brahe observed a great many things, and that led to Kepler's laws, not mathematics. And then Kepler led to Galileo, who was the father of science, based on his observations. And that led farther, eventually to Newton, who, and this is where things started going wrong, invented a new type of mathematics, calculus, in order to define gravity and the way things were moving. And the thing is he did an excellent job. He did the best he could with what he had, and he used the observations of the time to build his mathematics. And that went on for several hundred years and was the law until Einstein came along, and he did math that is just unbelievable. To be honest, I still don't see how he made the leap from gravity to general relativity. But he did, and it was mathematical. And his equations became so famous that they became the law of physics. That math is how you define physics, and you can't argue with the math. And that's not a problem, except that math is just a series of numbers and basic algorithms, which we call equations, that lead us to places that we couldn't see without it. And there's nothing wrong with that, except that you can't see where you're going. You're not observing something and then coming up with the math to describe it anymore. You're coming up with the math and then deciding how to build the models based on that math. And that's a problem. And that's a problem because the math is not wrong, but the models you're building to define the math are missing some huge things. We need to go back to basic observations and logic and make sure that the equations, that the math, is being defined properly. And this is where things have gotten dramatically lost. I tried to show in my last video about Einstein's field equations that when the Schwarzschild solution reaches the point of infinity, that it crosses a transitional plane, and when it does so, it reverses the charge and force, which removes the mass, the antipole structure, the inverted antipole, which gives mass and charge to particles. It removes that atmosphere, that inverted antipole, releasing the dark matter, which causes the radial flows of that dark matter to create the toroidal vortex that we see that creates the galaxies. The flat plane of the galaxy exists between these two toroidal vortexes here. It's visual, it's observable, and you should be able to see it in your mind as particles are pulled in along this plane when they get to the, well, I guess what you would call the edge of the black hole. The force on the charge pulls the charge from off the dark matter and spits the dark matter out, force out, and the charge goes into the core, and it separates the mass and charge from the dark matter. And this dark matter flows are what create the flat plane of the galaxy. But that's just one example. And as you can see, I suppose I drew it too small, but this is a model of our solar system. The Sun, Venus, Mercury, Earth with our moon, Mars with 2 small moons, the asteroid belt, Jupiter, Saturn, Uranus, Neptune, Pluto, which I call a moon, and its small moons. And then out here, of course, you get this Kuiper belt, and you get these entire shell around the solar system. And obviously it's not to any scale, but the point of this is to make you look and see observationally that there are changes. Now, in my previous videos, I've showed how a particle with velocity has force out below it and charge in, and behind it, the particles move back in, so it's force in and charge out. And this creates a transitional plane of density. And the quad outputs on that transitional plane of density are charge and polarity, as defined by Dirac's equation. When you define Dirac's equation, when you interpret it using Cantor's ternary set, as one, the other, neither, or both, or 0/3, 1/3, 2/3, and 3/3. And this is true of every field. And when the force, when the acceleration that's causing the field to form reverses, then polarity and charge can flip, which is how we define antiparticles and quantum tunneling. And this is reflected in our solar system when our star, the Sun, flips polarity. It goes from an accelerated state to a decelerated state every 11 years. And this is caused by the passing of energy in the form of moons inward and matter in the form of moons outward. And this happens at this asteroid belt. So if we're going to, and I'm not telling you the math is wrong, I'm telling you that the math is correct, but that they're missing transitional planes that flip things, that flip the charge and force from in and out along these transitional planes. And that's not in the math. If you listen to scientists who are defining modern physics and these particles, these planets around our star, everything's made of the exact same thing, and there's no differences. And that absolutely can't be the case. The reason this can't be the case is there are transitional planes you should be able to observe. The outer planets do not look like the inner planets. The outer planets, Jupiter, is an antipole. The red spot on Jupiter is this quasi-particle that you see here getting close to the surface of the atmosphere, and it's about to birth a moon. That's why these outer planets have so many moons. And it shows that these outer planets are built differently than these inner planets. So using my model and just observing the differences, there is a transitional plane in this asteroid belt. And there is another transitional plane in the Kuiper belt. There are 4 particles inside the core, starting with our Sun. Our Sun is a charge monopole, but it's in motion, creating a charge dipole. Observable. This is observed when you flip from acceleration to deceleration every 11 years. These 3 planets, Venus, Earth, and Mars, are rocky planets, and they are charged dipoles. Well, if you look up what an antipole, what the exact reverse of an antipole is, it's a charged dipole. This quasi-particle, this moon-making structure that's inside Jupiter and that forms from the antipole structure. When you invert an antipole, it is a charged dipole, and this quasi-particle flips to the outside and becomes a moon-making structure external. Since we can see that Mars and Earth, and if I'm right, and Mercury used to be Venus's moon, then Venus have external moons that form external to the planet, that can't form inside the rocky planet, then that quasi-particle is on the outside, and these are charged dipoles. If that moon-making structure is internal to Jupiter, then that quasi-particle, that moon-making structure, is internal to the atmosphere and pushes, as they accelerate, pushes those outward. And you can think about this like a Feynman diagram in your mind. When you add energy to the moon, this quasi-particle inside, it separates, right? And you will see, just think of a Feynman diagram in your mind where the electron goes this way and the small positron or anti-neutrino or whatever you want to call it separates from it. And this occurs, you can see it happening around Jupiter. So how does this function? Well, if this is what our galaxy looks like, and it is, then there is a black hole, which is a negatively charged core out here. And the star traveling through that creates an electric dipole because it's an electric charge. This is our star. In this toroidal dipole is, it's the galaxy, and this antipole is the universe. So the universe has a core somewhere. It's a negatively charged core. It's creating these galaxies, and these are negatively charged, and our star is positively charged. So the positive charge in motion creates a field around it, which creates these quasi-particle positions, which create planets. Those planets are charged dipoles, so they have the inverted antipole, which can cause moons. But because this charged dipole is in a negative space, then these planets, these 4 outer planets, matching the 4 positively charged, the star is positively charged, Venus is positively charged, Earth and Mars are positively charged. And they create equal and opposite vortices, whirlpools in space that are these outer planets. Which is why I say that these outer planets have a anti-gravity atmosphere that are antipoles, creating this quasi-particle inside that can birth moons. The inner planets and the outer planets are not the same. The inner moons and the outer moons of the planets are not the same. These quasi-particles, once birthed, will be positively charged dipoles, just like these inner planets. And they will have the antipole inverts and will create a quasi-particle, a place where a moon can exist around those moons. And that's it. That's how these things form. Positive, inside negative. So this belt is a transitional plane, the asteroid belt, between the star and the core of the galaxy. And the core of the galaxy, this will be this Kuiper belt will be another transitional plane. So the space inside here between the star and the asteroid belt, this space is positively charged. The space between the Kuiper belt and the core of the galaxy will be negatively charged. And this space in between will be a positive and negative charge combined. And the positive particles traveling with velocity, right, will create whirlpools, which are these outer planets. If you look at the transitional planes, if you just see a particle with velocity, will create a transitional plane where in front of it larger particles are pushed out and smaller particles, then energy, get moved in, and behind it those larger particles will then move back in and the charge will be pushed outward. And if you need to see this in your mind, if you need to see what this would look like in your mind, look at a jet. When a jet flies, the larger molecules are pushed out of the way and the water vapor, the very small particles, get pushed inward, and you get a cloud in front of the fuselage when it's flying fast enough, showing this force out, charge in system. And behind it you get the force in, charge out system, which makes perfect sense. So in any system where you have a particle, any particle in motion, you get a force out, charge in front of it, and a force in, charge out behind it. And this creates a field from a core outward. The star is in motion, in negative space, right? So in front of the star you have mu naught, right? And behind it you have epsilon naught. When you apply these, you create transitional planes that then create systems. And those systems can be observed without mathematics. But when you go back and you look at the mathematics created by all of these great scientists, you then see where it fits. The problem is most people have studied the mathematics without seeing a model that it actually works. So there are so many things that are undefined in modern physics. Why does the sun flip every 11 years? Flip its polarity. No one can tell you. I'm telling you. Why are there plasma discharge marks, right, on the moons in the inner solar system and some in the outer solar system around the other moons? Why can moons of the inner solar system not have moons of their own, and yet moons of the outer solar system can have moons? Pluto is a moon. It's not a planet. It's not a quasi. It is a charged dipole moon that has moved outward as it gains acceleration and has its own negatively charged moons around this positive particle. So how does this force work? Well, in this inner solar system, right, Newton's gravity defines it perfectly. As long as you're talking about charged dipoles being pulled gravitationally inward and yet being accelerated outward, right, they would fit exactly where they're supposed to be. The difference is the moons of these don't. Mercury doesn't fit Newton's model, and that's an anomaly, right? But it's only an anomaly if you don't recognize any of the other motions. If Theia was Mars's moon before it hit us, then moons of the inner solar system are moving inward, which means Mercury is not an anomaly. It's the path of magnetic monopoles, or what I call force monopoles, inward, while charged dipoles are moving outward. And out here, this is where Newton's gravity falls apart. Why? Well, because Jupiter is not held by its gravity, nor are any of these outer planets. What holds them around this star is charge. They are toroidal vortexes and anipoles created as whirlpools caused by these inner planets, the star and the inner planets. And there is a transitional plane if things form the way modern scientists say about gravity, then Jupiter should be the smallest of the outer planets. Okay? If these cleared more space than the inner planets because they have a bigger orbit, right, which is what the modern theory suggests, then the largest planet should be on the outside, clearing the most space, and the smallest outer planet should be on the inside, clearing the least amount of space. So the model doesn't work. So then they start saying things, well, Jupiter must have moved inward and then outward and cleared more space before these others. And there are other anomalies. Here's the problem with mass and gravity when you start to get out here and when you get away from the charge system. Mass is equal to its gravitational force. So how do you know the mass of Jupiter or any of these planets? Well, they take its location divided by the gravitational constant. That's how they get the mass. So it's a game with an unknown variable being its mass that can be anything. That's how they hide it from themselves. Jupiter and these Saturn, Uranus, Neptune are anti-particles, toroidal vortexes, which means they should have no mass or very small amount of mass. The reason that you can't see this is because you assume that gravity is a universal force, and you make excuses anytime it doesn't exactly fit. And the way that works, the reason it works so well is because its mass times gravity gives its location. So what happens when they're slightly wrong? They don't say, oh, there could be a problem here. What they say is, oh, well then the mass must be slightly different than we thought. That's it. You can hide any discrepancy by making mass whatever you choose it to be. They didn't go out and actually solve the mass of any of these objects. They simply say this is where it is, and if the gravitational constant is correct, and you can't argue with the gravitational constant, then its mass must be this. That's how you get to the mass. And its mass being whatever they say it is, because it needs to be for its location, right, for where it is in its orbit and how far away it is, then proves their gravitational constant. But it's a game. And the mass is measured by the gravitational constant. And so it can be hidden. It can be adjusted to anything you need it to be. Well, if you have a number that can be adjusted to anything, that's not proof of anything. I'm not disagreeing with the math. I'm disagreeing with the models you're using to build the system out of that math.